All right, we are live. Welcome to the Core Dev AMA. Maybe your first question could be, for me, could be, why are you sitting on the floor? But I'm not going to answer that. So we will answer other questions though. Yeah, welcome, and looking forward to hearing some questions. All right, we've got our first question. What is core?
This is simple.
Philip, you want to take
pair of
okay, Edward.
Battery and a context.
Yeah, exactly. Well, battery and payload.
Yes, no. I'll let Philip go with the actual answer.
Yeah, so for a long time, inside of Tlon, we used to refer to like infrastructure and interface as sort of this basic distinction. And this was somewhat confusing, in part because it's not what infrastructure means. I mean, it's kind of what infrastructure means, but it's not how people use infrastructure. And it also was confusing in that, well, it was basically, it was a weird split, a weird like terminology that you constantly had to try to explain to people. Core is we're using it in a very similar way to how everybody else tends to refer to core development in other projects. So what that means specifically in terms of the code is mainly we think of it as the runtime, the kernel, and whatever's in the base desk. So there are some user space apps there like Dojo, which is your shell. There's a user space app there that fetches your azimuth state. These are these are very sort of trusted apps that if they're not working, your ship is just not working. Right, there's even one there to ping your parent star and galaxy, which if you're not doing that, then you're not going to be getting messages from other ships. And so that's what we think of as core. It's whatever is required to keep your ship running on a basic level, which also includes some stuff that is even outside of what we usually outside of Urbit OS, right? The Urbit ID stuff tends to get worked on in a different way, but it is also basically core development in a meaningful way.
All right, second question. From the last talk, how would the network handle if your planet suddenly hosted viral content? A lot of home internet is rate limited, so I don't get how that would be solved on an Urbit level. Yeah, this is true. It's a good point. And so there are kind of two steps here, I would say. The first step is make it so that if your ship is not on a rate limited internet, that it can actually max out that not rate limited internet, right? So you need some sort of network protocol where you can distribute data to a large number of people efficiently without causing a bottleneck on the publisher. So the remote scry protocol is our first attempt at this. And so that uses Urbit's scry namespace, which is in a static functional namespace as it was described in 2010. But it's basically a URL system where every URL is a permalink to a piece of data. So we're going to expose that data over the network with a network protocol. That's another peer-to-peer protocol next to Urbit's existing one, which is called AIMS. And so that protocol will allow one ship to request the data at a path, and then it gets the data sent back over it. So doing that, so that protocol should be able to handle many simultaneous downloads without putting much load on the publisher. So that's the first step. But as you mentioned, if that publisher is my laptop behind my home internet connection, then yeah, I might not be able to distribute it to a lot of people. So I would say that the next step is to make it so that if I'm requesting, or if you're requesting data from me, and then the bandwidth isn't high enough, right? Then you could also start asking my star, my sponsor, for that data, and the star is going to be on the public internet, and it's going to have often, or it really should have, sort of bigger pipes, be running in a data center, right? Much more industrial setup. And so in that case, what happens is, instead of asking me on my dinky internet connection for the data, you ask my star instead, and it can have a cache. And it's a pretty simple cache to maintain because it's immutable. These mappings are immutable, right? So you never have to do cache invalidation at the star level. So it should be pretty easy and cheap for stars to maintain this kind of service. And then you should have a lot more scalability. And I would note also that a star doesn't necessarily need to live in just a single data center. You could actually have edge nodes all around the world corresponding to that star, or corresponding to remote scry more generally. And that's sort of like what Netflix does. Like they have deals with colos all around the world, so that they have edge servers, so that when you request some movie, it's somewhere close to you. So that's where we need to get to with that, in my opinion. There are also things we could do with gossip, as I mentioned earlier, where basically you could have ships that are not your star republish and redistribute content on your behalf. And because the signatures on that mapping from path to data, those signatures get propagated, anyone can distribute the data, and that's still safe, maintains the provenance. So we don't have something that does that now, but that's how I think about solving that problem. So I think there are a few questions here. Let's see if we go to the.
He put up one for us on the screen, which I'm actually trying to parse.
When stars and galaxies have differentiated service provisioning down their lineage. Yeah, I don't know what that means. Why don't we go to the other question? Cordis, why don't you try to rewrite that?
That's a good question. Is there a solution alternative for this data on disk constant writing, just slamming disk? Which I can take a stab at. I don't know if anyone else wants to jump in on that, but like there's on some level this is unsolvable. But I'll take a really zoomed out answer to it, which is, if you care about the fact that you did it, then you should be writing that to disk. There's nothing that, like, if you care about the fact that you did it, there's nothing, like, it hasn't happened until it's on disk anyways, in a meaningful sense. And so yeah, you just got to be writing disk. If you don't care about the fact that you did it, for example, if you're a publisher and someone asks you for some data and you're like, I don't care who's asking, I'm just going to give it out, then yeah, you shouldn't be writing it to disk. So this goes back to the almost some of the like quiescence discussion from the last stream of just like, yeah, write things down if it changes your state, if it's something that you care about, and that needs to happen fairly often if you want to have good latency on that. But for the things that you don't care about, for which even includes things like I'm pinging someone else to see if they're online now, that you don't care about the fact that you tried that over and over and over. You just care about hearing back that they are online. So that's the only thing that you get written to disk. That kind of approach, I think, can reduce that a lot.
I would know that there are a few other things. One is that you can do event replication to multiple machines, but that only just keep it in memory, right? And that way you're not actually writing to those disks, but you have you still maintain the invariant that you have all that data available if you need to replay. You actually do need to write that to disk eventually, right? But you can do it sort of in slow batches, right? Asynchronously. And So that's one approach, is you do event replication in memory. And there's a second trick, which is that if you have control of the hardware, which we generally don't, so this is a future trick, but if you did, then you could have a, you could just make sure that the device never shuts off without flushing its queue of incoming events out to disk first. And you can make sure that you'll always have enough battery life to do that. And this is close to a YOLO mode, but I think actually for most people, it would probably be good enough if that hardware stuff was reliable. So that's another answer.
Notably also, just real quick, things that today we would have to put through the event log really should be sort of don't care things. Like if you have a mouse event coming in for your user interface, that changes some kind of state, but it's ephemeral state. So there's probably a layer at some point that maybe we still want written in Hoon or whatever. Right now, this is your browser in JavaScript, right? But as we move that to Hoon, that you don't want to be writing every incoming mouse event to disk. That just isn't a feasible way of doing things.
Who wants to take the hosting cost one?
It's kind of a hard comparison because the costs are distributed so differently. Like, so in the case of like so how AWS is usually used for hosted applications, it's getting the application developer is paying for hosting, and that's going to be in general probably significantly less than all the different hosting costs for all the different people that would be using that in Urbit. I think what you do want to try to get somewhere near parity is sort of the marginal cost, where the so if you have people who are already on Urbit and they install a new app, it's going to use a little bit more memory, potentially a little bit more bandwidth, CPU, and that will in general cost a bit more. Usually that won't be visible to a user. It might be, that's probably chunked into large thresholds of performance or something like that. But if you think of this just in terms of like the global, how much compute, how much RAM of what quality, level is required, you want that marginal cost to be something similar to hosted applications. And I think it'll get close. I think it will vary a lot depending on the specific application. There are some applications that are probably going to be cheaper in a centralized environment, and there are some that are definitely cheaper in a decentralized environment, especially something like BitTorrent, as I understand it, is cheaper not just for the person who's publishing it, but it is sort of globally cheaper because it is somewhat because it takes advantage of the edge, basically, compared to pushing everything onto a single server. The sort of best of both worlds approach is put it on a CDN that actually exists in a bunch of different places, like that has servers in a bunch of different physical locations, and so then you can get some of those benefits as well. But if you're not doing that, then there are ways that making it decentralized can make it more performant, like asymptotically. There are ways that it can make it less performant asymptotically. Overall, it'll depend. I think we can get, I don't know, somewhere close for most stuff.
I think we can get close to the way I often think about this is that, if you look at a large cloud service like Twitter or something like that, they've all converged on having these giant distributed databases that are eventually consistent, right? So they don't maintain the like strong referential integrity and transactionality guarantees that you typically get from a single instance SQL server, right? So they relax that constraint so that they can shard the database over many different machines, like many thousands of machines, because you can't store all of the, you can't store all the data for a billion users on one hard drive, or even in one data center. Interestingly, if you compare, a whole world of, everybody lives in Facebook to a whole world where everybody lives on Urbit, then let's say that it's using the same set of data centers, but instead of them running, Cassandra or whatever, some big NoSQL database, instead they're running many Urbit ships. Then you end up with effectively a sharded and eventually consistent database, but where the unit of the shard is one identity. So one Urbit. And then basically, I think the way you would get up to approach the asymptotics of sort of centralized service is if the Urbit host can deduplicate data that's stored across multiple Urbits, and eventually even deduplicate computation that's run on multiple Urbits. And there are ways of attempting that, both of those with Urbit. And Urbit's sort of pure functional nature makes deduplicating computation much more feasible. You can just referentially, you can give a content address to a computation, and you could even run a zk proof of that if you wanted to. And then deduplicating data, the Scry namespace is one way to approach that. That's not a full solution, but I think it is one step toward a solution.
I'm definitely the newest one here, so I can just jump in and say to this question, I still wouldn't say I'm fully up to speed. I've got a niche that I can spin very fast on. The system's very easy to learn any particular part of it when you attack it, but there's enough different parts, it's a mature enough system at this point that it just takes time to even have reasons to go look at each part of the system. So I've been working on new Mars for most of a year and been at Tlon a little more than a year, and I don't know, I'm not new, but it's definitely not up to speed in the sense of like I could just easily jump into any part of the system and without any orientation say I know what's going on here.
I think I might be the only one of the people here who didn't actually start out in parts of the system that were previously described as core. Though back in the day, like my first project was working on Talk, Urbit's chat application at the time. Considering it was the only real application aside from Dojo at the time, maybe it was core in that sense. Certainly was a, like a fun and engaging way to get started. The thing I worked on right after was Azimuth, the Urbit ID PKI. And so, you like start by working on a core project and you explore what that's like. And in that case, you make it up from scratch. All of the other parts of our stack are like, at least in my case, I sort of just learned them on an as needed basis. It's like, hey, we need this feature or we need this bug fixed. And so, there's limited people available to do that kind of work. Go figure it out. Good luck. Of course, also cases where it's like, hey, this seems like an interesting thing I want to work on. And so you dive in and ask around for, many of the people on call here and many others who already know what those parts of the system did and looked like and, walk you through it. And so it's not a single getting up to speed. It's more like, oh, I'm going to figure out what's relevant to me right now, get familiar with how that works. And as we've, known to be saying before, it's like, it always ends up being not that deep. Like if you focus on a single part of the system, you can usually grok it pretty fast.
So I spent a couple of years watching Urbit development closely, contributing from the community. And, I turned on all the GitHub notifications and opportunistically looked for any issue that I could get involved in, or any little fix that I could make or something like that. And I thought I knew things fairly well in that mode. I read everything that I could. And after working on Urbit full time for probably 8 or 9 months, I would say it was, it was just a totally different level. So I'll echo what's being said by Edward and Mark very strongly. Getting an opportunity to go, really hard in the kernel or in some core parts of the runtime, there's no substitute for that. I remember very specifically hosting a live stream reading of the Urbit white paper.
I was there.
Yeah, it was a lot of fun. And it was sort of collectively, it was all, kind of peripheral contributors at the time. We could kind of collectively tease out what was going on, but it was hard, and a lot of things we just didn't really know what was being referred to. And after being on it full time for a year or two, I remember, rereading it kind of out of curiosity, and it just all seemed like, the most direct and obvious presentation of this material that you could possibly imagine. And so, yeah, stick with it. It's great.
Yeah. I would say it took me about a year to get up to speed where the way I think of that is getting to the point where I'm like, okay, there's any part of the system, I may or may not have touched it before, but I can go and figure it out and do what needs to be done. It feels like I was certainly contributing stuff to core before that. I think all of us were like, relatively early on. It was easier to do that when I was getting up to speed, because I also very quickly became responsible for breaches. And so it was like, oh, I'll just push this out. Oh, didn't work. I'll breach it again. If nobody checked their email for a few hours, they probably won't even have noticed. And so you can, release stuff very fast that way. And so that made it so that I could dive into more areas relatively quickly. But yeah, because I joined in May of 2014, and then by the time we get to January, I'm rewriting the Clay, and then that takes a couple months, and that's kind of the first very large project that I had in the kernel. And at some point soon after that, I was doing stuff in the runtime, writing bar mass, tracking down memory leaks, all that kind of stuff. And so by the time I've passed those milestones, and of course rewritten chat and the shell, there's a long history of core developers starting by rewriting chat. By the time we get to that, it's been about a year, and that's when I would say, yeah, that I was basically up to speed.
Yeah, let's see. For me, I first encountered Urbit right around 2014. Didn't really understand it. 2016, saw it again. There were some more docs. I started trying to understand it. And then I went through some Hoon tutorials, wrote an app, tried to get it to do networking, failed. And then I wrote a knock interpreter in Python. And that's when I really started to understand the system as a whole, just kind of not as a whole, but sort of holistically, like what it was about. So I actually highly recommend writing a toy knock interpreter if you're interested in Urbit, because it gives you a feel for how it works. And the easiest language to write a knock interpreter in is, of course, Hoon. And so that can also teach you some Hoon. But so I did that before I started working at Tlon, and then mid 2017 joined Tlon. And so I knew some Hoon, and then I started working with Hoon. And I was so my first project was to write the SecP 256K1 implementation in Hoon, and that was a nice intro actually, because I didn't have to know much Hoon to do that, and so I was able to do that pretty readily. And then I worked in the Udon parser with Anton, which was very difficult. Don't recommend that as a first project. And then ended up rewriting Ford for a year. And by the end of that year, I would say I knew a lot more about how the system worked. So yeah, the first 6 months, I actually I was concerned that maybe I had lost my ability to write computer programs. Maybe I had a brain injury or something, and then it came back. But, yeah.
Oh yeah, so this is
Okay.
this is the question from earlier, I think.
Yeah.
And if I understand it correctly, it's already true today, right? There's nothing stopping galaxies from, or stars or even planets from distributing a base that's different from what gets published on Zod. There's also nothing stopping that alternative version of base of like automatically installing other software packages. If you want, like, if you're thinking about like, passing software down like on boot, it's like, yes, the base thing will also take care of that. You might, provide user documentation that sets them up with like pre-installed software right off the bat. But yes, all of that is, already possible today.
I'll
Yeah,
take the
although
second half of it and say it's really not something that I'm looking forward to. I won't pretend to speak for anyone else. Kelvin versioning implies a kind of agreement about the thing being versioned. It implies a linearization of the development and distribution process. And I think what's ideal for the network is, strongly shared foundations upon which, a beautiful garden of, rhizomatic structures can blossom or whatever. But I think
never
that
thought I'd hear you say the R word.
Kindly restrain yourself from forking base or distributing your fork of base. PR it upstream, please.
Yeah,
I agree with that. And well, actually, I would sort of take that a step further and say that, and I wrote something about this somewhere, maybe on Twitter, but the way I see this going eventually is that unless you've deliberately forked your kernel and you're running something else, which you can always do, it's your computer, right? But unless you do that, and then you're on mainline, and you're using the Kelvin versions, then each new Kelvin version will have some sort of attestation from a set of ships. So it'll basically, the code for that Kelvin, the hash of that source code, or maybe its resulting knock, will be signed by a set of ships who have been designated as the ones who have to sign off on any Kelvin version. And not only will it be signatures from those ships, but it should be signatures using upstream keys. So keys that are kept, that are not stored in the ship and are used, only brought out of cold storage for the purpose of signing a Kelvin release. And that way, even if the whole network of ships who are distributing updates get pwned, users still will not end up downloading a malicious kernel, unless you actually pwn all those individual devs and their cold keys, which is a significantly more difficult problem. That's one idea, and that's not. I don't think that's been sort of firmly decided upon, but that's how I see it.
Yeah. Now there's a related idea. So there's this question of what is your base? Was the core development part of it, or like the core system that you're getting from these different ships? But what should diverge is like what apps are installed when you start your ship, what groups you're perhaps automatically installed on, automatically a part of, and that sort of thing. That is, I suspect that will largely not be based on your lineage, based on what star you're under, what galaxy you're under, and will be more based on sort of how you got on Urbit. If you're using a hosting provider, they might have their hosting support group on there. They might have apps they recommend. They might even present you options of like, okay, are you a developer? Do you want that template? There's a bunch of options for how to implement that kind of thing. I've started circulating a proposal called what I've been calling a Lure service, Lure, which is one take on how we can make that sort of more appropriate for the people, getting on Urbit. I'll see if I can put a link in somehow.
Cool. All right, so this next question is thoughts on potential future development on advanced dev tooling, IDEs or language servers, for instance, or something like custom linters or auto formatters for example, smoothing over back and pad breakage.
I'm just going to jump in and say that formatting Hoon is a work of art, and you'll pry that from my cold dead hands.
But there's a lot of tools that could still be used for it. Anything that can do like that can line up your lines is important. Auto indenters basically work fine. You could modify them slightly. A linter could certainly identify some issues. It will not identify all issues. I think that like I'm much more interested in sort of higher level tools of the kind that Oakbar is trying to build, right? Where like their testing suite, which they're trying, which they forked Aqua and are working to integrate that with that as well, where basically the startup cost to getting a desk running, writing your code in it, running tests on it, like that whole flow can be made much faster, much nicer, and much more like it should be able to display much more clearly sort of what state you're in. This whole thing is a very it should be a very legible system, right? They're just nouns everywhere, and we should be able to just display those. But it sometimes feels like we're poking at it sort of with a lot of distance between. Like it feels like we're using electrodes or whatever to flip bits on a hard disk sometimes, when the whole thing is nouns and they could just be displayed everywhere. And so that's I think there's a huge amount of progress we can make on that, and we should do it as soon as we can.
Yeah, step through debugger would be really cool. Also, Philip wrote what did you call it? Bent something? It was the Hoon interpreter.
Oh yeah.
Do you remember? Anyway, it was cool.
Yeah.
And you could pretty easily build a debugger out of that, with breakpoints and whatnot, and stepping through. The other thing I think would be really cool to see would be a something that maybe even just repurposes, either build something similar to or repurposes the Chrome JavaScript inspector, right? Which shows you the closures and all that stuff and all the local variables, and basically just build that for a knock subject, like a Hoon type subject. I think would be very cool. I think, yeah, I agree. There's a ton of stuff to do on dev tooling. As for IDEs, what I really want there is just key bindings for Vim or some similar editor to use the Hoon runes as navigation, so that I can hit up to go to the enclosing rune, hit down to go to the first sub rune, right to the next one, the siblings, etc. Because that would be a very efficient way of navigating Hoon file.
I'll just add that, I'll echo what Philip and Ted are saying about lots of low-hanging fruit and using very primitive tools right now, but then also add that this should not simply be considered like a programming question or a language tooling question, because you have a whole system here. And so there are related dimensions, a possible namespace explorer, or integration in the event log. There's a tremendous amount of data that is at hand that could be visualized or exposed in different ways. And the things that make Hoon or Nock exciting in this dimension apply to the overall system as well. It's just a value. It's more direct and declarative than anything else you've ever encountered. And so we haven't even begun to scratch the surface.
Yeah, focusing back down a little bit from what Joe said about that in particular, the distance between Hoon and Nock is so small that the kinds of attribution issues you run into trying to build tooling for any other language, where you're going to, like, if you're compiling even C down to assembler, and then you want your debugger to tell you like which C statement you hit. Well, this is there's some ambiguity here already, whereas in Hoon, you just have a noun and it fits the Hoon type of your subject. And so you can just say what the value of every face is. There's no elision there. There's no difficulty with these attributions. And this is one reason that this property is so important, I think, to what Urbit is, that this is one reason that when people propose adding really sophisticated things into the Hoon layer, that you're going to notice there's some pushback in there. Like, oh, why isn't Hoon an optimizing compiler? Well, this is why, because this property is really important for the system that we're trying to build.
Yeah, and that'll be clear when you have tools that make that more visible to people.
Yeah, Hoon is pretty unusual in being a production compiler that is not an optimizing compiler.
Co-hosting landscape groups. I can talk a little bit about this because we actually used to have something like this back in the day. The old chat talk that I mentioned earlier had built-in support for federating chat channels across multiple ships. It was baked into the point where if a galaxy hosted a chat, all the stars under it would automatically try to federate it also. And then the planets could say, hey, I just want to join Urbit Meta from whoever my sponsor happens to be. And it would, go to the star and send messages there. And they would get like routed up and back down all across the network. This was very important back then because Urbit was even slower and less stable than it is today. And so to support the, meager but somewhat sizable number of people on the network back then, splitting the load like that was important to do. I think today, and like the world we want to be heading to, federation will primarily be useful for guaranteed uptime. And others may want to correct me if this is wrong, but I think performance-wise, like an individual star, we definitely want that to be able to host a chat group that serves hundreds of thousands, if not millions of users. But yeah, the one thing you cannot solve for there is like, well, what if that thing goes down? Like, is there still a place you can go to like keep talking in that same chat room?
So I would circle back to Ted's earlier comments about the namespace and the remote scry protocol in particular, and say that to the degree that these kinds of use cases can be sort of solved automatically and orthogonally, that is dramatically superior, right? You could think in a fuzzy sense of what we're trying to build with the remote scry protocol as, embedding a CDN almost implicitly into the network. That being said, there are probable use cases for federation, and an almost entirely unlocked dimension here is that all azimuth identities have 4 billion moons. And so I believe Wexpert Systems had or was working on a proposal for using moons in this way. And I think that's quite promising. I would still prefer, of course, for it to be, zero config automatic. But there are real options here.
Okay, the next question is thinking about the eventual balance of power or responsibility between levels of the network. If one wanted to run a business on Urbit, should they own at least an X, with X as a planet or a star or a galaxy? I would say you should at least own a planet so that it's a permanent identity. Beyond that, then it does seem that people have been owning stars and sometimes galaxies, partially in order to just sort of demonstrate skin in the game. But I think this is actually pretty hard to predict, frankly. And I don't think there will ever be a sort of a strict codified requirement that you need to own anything above a planet in order to run a business on Urbit.
Yeah, I agree. I think owning a star, using that as a relative public part of your identity, the main thing it does is it sort of demonstrates a base level of seriousness, I guess. But there's not there are very few things that like on a technical level require a star. Obviously, if you're giving out planets, you need to get those planets somehow, and a star is a normal way to get those. Yeah, I definitely, I probably wouldn't use anything from a business that doesn't have at least a planet, though.
It also depends a little bit on what kind of business you're running, because the business can run the gamut from your farm stand on the side of the state highway up to a nation state. So it's just a question of what capabilities do you need from your identity. And for a lot of use cases, just a planet is fine. If you need to be able to issue identities to other people, then you need a star. It's hard to imagine a case where you need a galaxy for your business.
Unless you're selling your Senate vote.
Point out.
There's that old joke from the Mel Brooks movie, History of the World Part 1. So, we have the best Senate that money can buy.
The expected timeline for app levels sandboxing / permissions, I can maybe take that since I'm working on the first iteration of user space permissions right now. So I am working on it. It's already in a place where it functions. I'm currently trying it out on all of the software packages that Slon has built, and seeing how that how that feels, how that operates. Some things already jumping out to me that need a little further tweaking. Hard to give an exact estimate. Probably not going to be released this year anymore. Sometime Q1 of next year seems reasonable, but that's still going to be a first iteration of the permission system, which only lets you it only applies to apps that you run locally, and you only get to say what is this app allowed to do, yes or no. So nothing about things coming in from other people. That's still managed within the applications themselves. It's also not a full capabilities system, which we may or may not turn out to be necessary at some point in the future, but we're definitely not going to start exploring the space there.
I'm just going to jump in and say that apps are already sandboxed. They're run zero cost in virtual NOC called mock. And that's been the case since 2015. And so in many important dimensions, the system is already protected from them from a computational standpoint. The permissioning work that's being done here is in reference primarily to I/O, or communication between apps and the kernel. the data in the namespace that the apps can access. And there are significant latent capabilities in the runtime to further restrict the resource usage of apps through the virtual interpreter. You could set upper bounds on memory usage. You could set bounds on wall clock time, CPU time that a particular activation of an app uses. And
I still think the Urbit as hard real-time OS is really funny, and we should do it if for no other reason.
yes, it's awesome. And there are also pretty well vetted early stage designs for unlocking parallelism at multiple layers of the system. And you know, the separation of agents is a sort of natural locus for that as well. So much more to come.
This
is in reference to
I'm not sure.
owning a star or galaxy, or the earlier question.
Yeah, I think search, routing, those. I mean, it depends exactly how you mean by routing, but as I understand it, yeah, that there's no real need for a star on something like that.
I've always imagined this as the star being sort of the natural locus for ISP style services, and maybe just eventually the category, the role that replaces what is, currently provided by ISPs, but really more older style, local ISPs. So,
yeah, I mean, although notably older style local ISPs used to provide things like email addresses that, I mean, they often still do, but
yeah. So I'm thinking of CDN services, or store and forward, or these kinds of things at the
providers
level.
For Bitcoin and ETH nodes, stun servers.
Yeah,
right.
Exactly.
Well, all right. When does knockfs or Urbit hypervisor fit into the roadmap? Knock crystal tier imaginative speculation encouraged. Well, I don't know exactly what knockfs means. Knock file system, I suppose. And then, I mean, I do think that Urbit does not make full use of POSIX file system API. So a much lower level interface to a block device, where you have maybe, I don't know exactly what that ends up looking like. Maybe you have a custom B+ tree that stores your snapshot and all the other older snapshots. Actually, Edward, you probably know. You've been working on a bunch of stuff like this. You probably have a much more concrete vision.
Right. So I'm going to take a wild swing and guess that knockfs refers, especially paired with a hypervisor, refers to like deduplicated nouns across multiple ships. And the answer to that is just that, yes, this is something you can do. And this is something that you can do more easily in a differential snapshot system. So we're working on a differential snapshot system. So when in the roadmap, I don't know. Who knows? I won't even say when the differential snapshot system or any of this other work fits into the roadmap. So I don't know. But it is
our
something.
Snapshot now not differential?
Joe's better place to answer, but the sort of thing that's being built for new Mars is like things don't move around when there's a snapshot, or really ever.
I see.
At least in the virtual memory space.
Yeah, an important dimension of questions for this kind of use case is the degree of orthogonality of such a system to the sort of like object level expression of the data in your Urbit. And so on the totally orthogonal side, there was some discussion of demand paging in the roadmap. And this is also what Edward's talking about in regards to the design for the snapshotting system in New Mars, which is actually more similar to Ver's system than many might think, but there's some important optimizations in that new design. And that's, the virtual memory approach is, sort of purely page based, and which means just chunks of the address space and some fixed size. It usually varies per system. The totally, aligned sort of semantic system here would be to say, I have a file in clay, or I have this core, right, that I just built for some user space agent, or in a solid state subscription system, I have the state of this publication at some Aeon or something like that. And I actually want to identify that as a granularity of data that I care about entirely. And if that's a tree, maybe then the tree could be packed in memory. It could be represented in some succinct data structure. The general name for the buckets of ideas here, the non-orthogonal representations, is a grains system, punning off the granularity. And so there are major strengths to both approaches, and also significant trade-offs. And in the presence of such things, I sort of like to say we should try both. But generally, we've gone further on the page orientation side of things, and the big step that would need to happen for that to work more broadly in a hypervisor kind of situation is just a page-aware allocator, right? Because if you align things properly and you say, the atom is always going to, if the atom is bigger than a page, it'll always start on a page boundary or something, then it's easier for the underlying environment to handle that. Probably not worth going any deeper on that, but yeah, lots to be done in that area as well.
When will stars route packets for child planets without going to the galaxy? Use case, I want to build a local mesh network for Urbit that can function if segmented off from my ISP. There's a proposal that includes a specification called symmetric routing, which changes the peer discovery and routing that Ames uses. But part of that work would actually get stars to start to route. So you can check that out. That's something that could be built right now. I think the hardest part of it is probably doing the migration of the existing routing scheme that we have right now. But it would require some work on in both C and in Hoon to change that. As for mesh networking, we would basically, I think Ames is still not as much of a true overlay network as it should be. And so figuring out, how would we overlay Ames over something that's not the IP network, even just not the IPv4 network, is something that we have discussed some, but have not nailed down. I think the tough part is that we want it to always be the case that, you can at least find some way of communicating between my Urbit and your Urbit. So you need some sort of baseline shared protocol, but you also want to basically upgrade that protocol to something that, uses something more efficient if you can. And then, so the details there are somewhat complex, I think, to get exactly right. And so we haven't totally nailed that down, but it is, I would say that's how we think of that problem generally.
Yeah, I think there will be, just like there's always going to be a variety of transports that you might want to use, there will be a variety of ways to discover peers, and an obvious one is, especially on a local network, to just broadcast either who you are or broadcast a request saying I'm trying to talk to so and so. And obviously you can't do that on the public internet, but for a local network that can work. Mesh networking, it depends how big it is and so on. There's variations on that, but we definitely want to support that at some point. Yeah, I mean, it's exactly what it says, but seriously, which is that right now, while your app is sandboxed in the way that Joe described, it has, it's able to give commands to your Urbit, and right now we don't filter those at all. So anything on, or basically anything that could happen to your Urbit, any app could do it. And so if you basically installing an app is no less of a trusted operation right now than switching your OTA source for your base kernel, because that app could do that, for example. So yeah, basically, trust the app. Sorry, only install apps from people that you trust with whatever you put on your Urbit. So in general, that means don't put too important of things on your Urbit, and don't install apps from people you don't trust.
Yeah, and to be clear, the work that Palfun is doing on user space permissioning, which is described in the roadmap, or directly addresses that issue.
I think there's a lot of funny guys on Twitter. I don't believe that there was a galaxy in an orange at assembly.
Oh, I believe it. All right.
Did it ever leave?
I don't think it
I
ever
think the
left.
what hoon syntax is still there. Yeah. But actually,
the
one
print out
thing
the type, right?
Somebody bring up a prompt here. Can we share our screens?
I mean, I actually do think one thing I didn't put in the roadmap that maybe should be in there is that the Hoon pretty printer really could be a lot better, in my opinion. I think you should, in particular, there should be an easy way to call it where no matter what you tell it to print, it prints it within a few seconds, as opposed to potentially crashing your ship.
Ted has never gotten over the trauma of 4 consecutive Ford rewrites.
It's true. It's true. Well, look, I mean, if you try to rewrite four times, then you will be just as angry at the pretty printer as I am. And yeah, it's a good hazing for a new developer. All right, go rewrite the pretty printer. Actually, we have some ideas. Joe had some interesting ideas for how to rewrite the pretty printer in a way that might be easier and maybe even more principled, involving using the type hint, the send hint type for types, treating that like a mark, and then allowing you to write a function that describes how data of that mark could be pretty printed, and then you could write a pretty printer that where the logic of the printer itself doesn't know anything about those and is very dumb and generic, and that could be really nice.
Yeah, right.
So
now,
I should write that up at some point.
The printer tries to heuristically match the type, and if you're working on the build system, for instance, and you get something wrong, hilarity ensues.
Yep.
Oh, I see a
All right.
follow-up in the chat about the what hoon syntax.
Oh yeah.
This is never coming back. This is in reference to keyword AST nodes.
Keywords are never coming back, and we should never speak of them again. Thanks for listening. The hour is up, but so I think we're going to close this out. But I appreciate the questions, and take it easy.
Bye.